All right, I've gone ahead and started the recording now. So this is the April 10th, 2018 Rook Community Meeting, and let's go ahead and dive right on into it. So let's take a look at any of the lingering 0.7 issues we have. Let me make this a little bigger too. So has there been an update on this issue about the Rook agent formatting an in-use volume? I know last time we assigned it to Wyman. I don't know if there was an update.
I know he added a comment to it and question about.
Yeah. So that's the exact reason. The Kubernetes switch from LS BLK to BLK ID. So I believe that is the root cause based on what he gave the outputs and what happens over there. But never come back.
So we need to ping Christian and see if he's able to repro again.
So from our understanding, does that mean that this will no longer reproduce on 1.10 Kubernetes and higher?
Right.
Excellent. Do we happen to know if Christian and his team has moved on to 1.10 yet?
I don't really know him very well, so.
And then, okay, so maybe we can add a comment here asking about that. And then have we, so this comment here about installing the UDEV rules, are we saying that that is a workaround if you're still before 1.10?
Before 1.10, you need that workaround, like the UDEV rules.
Oh, okay. Okay, cool. I'm just going to send a little note to Christian here real quick.
Are those UDEV rules required, or what did you mean?
Did any of y'all have a question or an answer for Alex there?
I think that's what we're saying. The UDEV rules are required for while we're still using LS block. But Kubernetes 1.10 changes that. So it's not necessary anymore, right?
Okay, there we go. So just another ping to him to make it a little bit more clear.
But this doesn't happen every time. I don't think I have ever had this issue. And I don't have those UDEV rules.
Travis or Wyman, do you all have any understanding of why that would be?
Sorry, the file is just if you. I think it should be. I'm not sure about Ubuntu or just something else. But if you just install self-common package on CentOS, I think you should be able to get that the rules. But if that is the latest, it depends on this. I think it depends on self-release.
Well, and this, from that issue, it's not something that happens all the time to Christian, as I recall, unless I'm thinking of a different issue.
That's kind of what I'm trying to say, because I'm also on Container Linux, as I think Christian, and I don't have those rules installed. I don't think I have ever had this issue.
If you install Ceph package on somehow, you may.
No, there's no Ceph on it. It's just a plain Container Linux. That's the weird thing.
All right, so it sounds that we don't have a complete understanding of why it reproduces in some instances and it does not reproduce in other instances. The Christian and his team is the major folks that I've seen affected by this. So I guess we can continue to focus on making sure that it's solved for him and his team and his environment. And then if we happen to, get a deeper understanding of the root cause for, why it affects some people and doesn't, then that would be good. But since it's going to be fixed or is fixed, apparently in 1.10, that becomes a lower priority for me, in my opinion. But yeah, getting Christian and his guys fixed is definitely a high priority for me because they've been bitten fairly hard by this, and they've been pretty active members in the community as well. So I want to make sure that they're taken care of.
Yeah. Yeah, well, let's ping them on Slack too. Waman, do you want to ping them on Slack or?
Yeah. Okay. Don't
or I could. But...
Okay. Yeah, definitely.
Okay.
All right. So let's. So Alexander, you and I talked about this, I think, yesterday. There was on Slack. There was a user discussing an issue that they're running into that originally looked like it was due to this bug here about the Helm job that waits for CRDs to be created. But after further investigation, it was from a different issue. So I don't believe that we need to go ahead and do a release for that particular issue on this issue here on the 0.7 board. I don't think that we originally wanted to opportunistically release this if we're happy to do a patch release, but it looks like that user is not affected by this bug, so I don't think we need to do a patch releases. Do you agree with that, Alex?
Yeah, it was. Okay. I just thought it was this issue.
Okay.
But we should fix the underlying issue with the 2 containers when using sidecar injection.
Yes, I totally agree with that. I opportunistically added that to the 0.8 milestone as a like to have. It's not in, added it to the project, not the milestone. So it would be nice if somebody could pick that up and fix that. But it's, I don't have, I'm leaving the country tomorrow, so I don't have the bandwidth to do that for sure. Yeah, but we're tracking it here.
Sorry, so which issue was the other one? The multiple containers per pod?
Yes.
With Istio?
Yeah, 1633 right here.
Yeah, that one, I was just taking a brief look at that. I'll try and pick it up if nobody else can.
Okay. It's, did you add it to the 0.8 mile? Oh, 16 minutes ago. You're more recent than my recollection was.
I saw you added it to the project, and I figured you intended to add it to the milestone, but...
Yeah, I added to the project for a nice to have, and not necessarily committing to it for the milestone. But if we, if you're going to do it, then that would be great. I'm going to add a comment too, also, because when I was looking through the OSD code earlier today, that there's another place that could be have an effect.
Okay.
Okay. Alrighty, so that's 0.7 stuff. So it sounds like then that if we can get Christian's team unblocked and taken care of with either moving to Kubernetes 1.10 or installing UDEV rules, then we will not have any more patch releases that we know of for 0.7.
Sounds good.
Okay. Let's look at 0.8 real quick. So the scope of 0.8, Travis, do we have concrete plans about a timeline for 0.8? I don't think we've been making a lot of traction recently, except on the big ticket items like multiple storage providers and some of the bigger Ceph items.
Right. Yeah, and I feel like at our last meeting, I think we talked about shooting for having the 0.8 for KubeCon, which really only gives us 2.5 weeks before getting on a plane and heading out there. And if we're trying to get some of these bigger items in before then, that even we're at risk for those too on that time frame. So your question as far as making traction, I agree, especially with all the things in the to-do column there. We need to really decide what we're going to scope it to, and all that. So should we start by talking about the big work items?
Yeah, so the biggest thing on let's do that. The biggest thing that I am aware of and that I am entirely focusing on is supporting multiple storage providers. We would like to possibly get an initial implementation for one of the smaller, easier ones as well, something like Minio. But it would be nice to show that off for KubeCon. But so I'm hoping that there's something very concrete is ready and available by Copenhagen. What are some of the big other issues, like in the Ceph domain? What are some of those things that we want to accomplish there? Actually, we should pull the roadmap up too. That would make this conversation a little easier.
Well, the 1 LSD per pod is the biggest one on my mind that Waman's working on, and I'm looking at getting to work in OpenShift better. Let's see, what do you got there? Yeah. We need to remove mimic support, and all right, supporting 1.7 or removing 1.6 essentially.
And by the way, too, from the Rook user survey that we did, we got about 25 responses for it, and 0% is on Kubernetes 1.6 or earlier.
Yeah.
So that seems to be very good support for nobody really being affected by removing that support, thank God.
Yeah, and that's a big thing because we don't have to worry about supporting TPRs anymore.
So I think that so some of these things here, this roadmap needs to be updated a little bit, but having something to show here is entirely reasonable and still in the plans for KubeCon. Having a actual release that's gone through the full release pipeline and testing and vetting and all that is less likely and much more at risk.
Yeah.
So that's my concern about having a official release before KubeCon versus some demonstrations for KubeCon.
Yeah, that's what I was thinking too. If we can just show, hey, this is working, it's in master, and soon we'll have a release with it. That feels like a more realistic expectation for KubeCon.
I'm also wanting to keep some of the scope of 0.8. I would feel a bit concerned about chopping a lot of the things that haven't been touched yet, just to get an official release out before KubeCon.
Right.
But that's certainly open to debate. But I would feel uncomfortable with that.
Yeah, I agree. We need to get some of these things, like 1 OSD per pod, I think is a critical part of this. And if we're saying that needs to come after the multiple storage backends, and there's also, sounds like people out for vacation, or there's no way that's done before KubeCon. Just that alone.
Yeah. So it sounds like that's I would like to have things completed that we can demonstrate, but not necessarily an official release. So let's, if we have strong objections from anyone, then we can raise that now. But it's also, that would be something to talk to Bassam about as well, to get his opinion.
Yeah. Is there any other opinion on that in this group? Or are we okay to not rush 0.8? I'd say we're good for this group.
Okay. All right.
It looks like we need to update a few things on this list too. Like we're not switching to API aggregation anymore.
Right, that's gone as well. Mimic support is not as
or arbitrary PVs.
That's something that could still be in scope because, as part of the design for multiple storage providers, the storage scope spec, has a design for how
Oh,
that
that's
would be
right.
incorporated there. So that could be something
Okay.
that's in spec, in scope. Travis, could you do me a favor since I'm leaving tomorrow? Could you follow up on updating the
Okay.
roadmap a little bit?
Yeah. Okay. I'll do that.
Thank you. I appreciate you this time.
And yeah, just looking through this real quick. So remove the API aggregation line, migrating to the CI pipeline to CNCF. I think we're saying that doesn't, or do we want to keep it in there for now?
No, we've
Or-
started that conversation with the appropriate working group in the for the CNCF, but that's going to be a long road
Right.
to travel.
That's what I figured. And
Yeah.
it's really quite independent from a release.
It is. It is entirely independent from a Rook release.
Mm-hmm. Okay. Yeah, and then running least privileged. I think parts of that, I might think how to split that out because parts of it will get done.
And parts of it
but
are
others-
done as
and
well.
are done. Yeah,
Right.
exactly. Shutdown restart issues.
Having a tangible one of those to commit to or track down would be nice.
Yeah, that's what I was thinking. That's
Yeah.
kind of a general work item.
Yeah.
And then-
I would
That's good.
love to do that with 0.8. I'm very committed to getting that done.
Right. Disk management, I think if we focus on one OSD per pod and 0.8, adding and removing disks could wait, or we might keep it for now, I guess. Placement group balancer
Come on.
support, I think that may come with Mimic. And non-reliability. Alexander, you're going to say?
Yeah, that seems still for a good amount of people like an important point, or at least depending on how you see it, it depends on the operator can just do as much as it can do, to put it like that. At least in my case, for example, with my cluster, I never had issues with the mons.
Mm-hmm.
And because I know I need to maintain a quorum, and well, and if one fails over, yeah.
Mm-hmm.
Yeah.
Yeah, so you're having good luck in your cluster. That's our good results. Reliability.
Well, that also helps that Alex is one of the best Rook storage administrators I've ever met.
Right.
The cluster's already in good hands.
It's just 57 terabytes. Come on, man. It's just 57.
It's just
Only 57 terabytes.
okay. So Travis, you'll follow up on
I'll
updating
do
the
that.
roadmap. So let's go ahead and move on then. So Dimitri, we have Dimitri has prepared a demonstration on how Nextensa Edge runs inside Kubernetes, which is going to be very informative for us. So Dimitri, I'll go ahead and pass it off to you if you're ready.
Yep, sounds good.
Awesome. Let's see if I can find the button for that. Oh, stop share. Okay. There we go. And Dimitri, do you on your screen, can you do you have the start sharing button?
Yep.
There we go. Nice.
Right. Okay, guys. So just wanted to prepare a real quick demo for how Nextensa Edge integrates with Kubernetes. So here we have a console. I prepared some YAML files. I'll go through it really quick. I don't think it's going to be more than 10-15 minutes, really. And we're going to talk a little bit about how we discovering disks and the network, etc. So right now, this cluster is really, it's just 3 nodes, essentially nothing special. It's version 1.10. We also have on each cluster 3 disks, and they're already pre-mounted into the match target data, local persistent volume. And we actually support both file system and also block devices, raw block devices as well. Very similar to how CF does with the Blue Store, by making essentially usage of SSDs to optimize placements of the metadata. So what I'm gonna do first is essentially show you how the network's laid out, so you guys understand. So we're gonna do kubectl get networks. There are two networks here created. One is essentially underlay for replicast. This is essentially a backend for the storage, and it is again, Kate and I stressed I think enough that the backend requirement is important. Not to say that if you do not do backend, there will be a problem with performance down the road. So the backend for CF and I think for Nexent Edge is specifically critically important, and for CF as well. So the client net is essentially a pod network, and it's just a normal overlay. We're using Contiv. So let me go to just Contiv really quick, and I'll show you what we have here. So we have essentially a multi-tenant network. Taking time to load. Now let me check if it's still working here. So we have essentially a demo tenant created and default tenant, which will be running the pod. This is the pod network. This is the demo tenant network. So let's go ahead and just review really quick how an Edge backend can be started. So if you take a look on target, so we have YAML files here. One is LFS, one is RD for the raw disks. We're gonna work with LFS. So nothing really special here as we're defining location. We define the networking interface we want to use for the backend. We're also defining the location of from inside the container to take the pre-mounted disks. And we then basically just exposing two networks to the target containers so that network will appear. And we're just running essentially the actual daemon and few sidecars, the audit service, which essentially aggregates the statistics and sends the statistics to the management framework, and the protein, which does the internal coordination for flex hash tables. So what I'm gonna do is gonna go ahead and start and create this target first. So while it's creating, what it does, it automatically discovers those locations, configures the disks automatically, builds flex hash tables automatically. So there is no, like in case of CF, there is a monitor which does essentially the monitoring for the file system. In case of Nexent Edge, we don't have a metadata server. Each disk essentially has a slice of metadata and operates as a metadata server. So if we look for where we are, it's already up and running. We have 3 containers in each. So again, 1 daemon and 2 sidecars. We should be able now to go ahead and start, for instance, the REST management. And I should talk a little bit about the REST management. So we have this YAML script. I'm using Node port to expose the ports, but essentially it basically accesses the same backend interface and also exposes the REST API. Additionally to that, it provides the GUI. Let's start that as well. right, so let's see. It's running now. Let's go ahead and check. My network is not great today, but let's hope it works. So there goes up. Okay, so now what we need to do, we need to initialize the cluster. For that, I have an alias, which I will prepare. So that I gain access to the NADM management tool. So essentially, it is seeing all the nodes, all the disks. So if we just display like this, it automatically picks up and builds up the flex hash table. What I'm gonna do now, I'm gonna initialize it. And it will create a cluster. We now should be able to log in. So what you see here is essentially a view of the NixNetEdge cluster. It has support for multi-tenancy, and essentially what we're trying to do here is to use Contif tenancy framework and connect network isolation with the storage isolation. And that's what I want, kind of the goal of the demo, just to show this up. So what we have first is the cluster namespaces. We can create many logical cluster namespaces. So let me create a few. Those are sharing the same storage backend, so to speak. We can create a few more. Now, within each logical separation at the storage level, we also have tenant separation, so we can create a few more tenants. For this purpose, I'm going to create two tenants. One is going to be default tenant scope, another one will be special tenant scope. So the test tenant will be default, and demo tenant. So once the tenants are essentially created, you can, like for instance, create buckets, but it could also be done to the console too. We then transition to the services. Similar to Ceph, Edge provides ability to create multiple services per single storage cluster. iSCSI NFS, this is scale out NFS, S3, Swift, and IHW. So let's create a few services here. Create iSCSI SVC. We create NFS SVC. We create S3 SVC. We create S3 SVC demo. So this service will be specifically isolated into the demo tenant network. So let's take a look on internals of the S3 service. Here we can essentially define the particular nodes to run on, but also we can select and pre-select what tenant it has to serve. So this is the default tenant test. And this is going to be default tenant. This is going to be same cluster namespace, let's say, and it's going to be tenant demo. Now that this is created, essentially, it can be enabled, but it can be enabled also from the console right here. What I'm going to do, I'm going to show you the YAML files which it will generate. Like for instance, in case of iSCSI, you will see that generates the standard iSCSI service. it initiates the service and starts it up. It is scale out iSCSI. It also, what's interesting about iSCSI, I probably should mention, is that both iSCSI and NFS, they essentially provide a way of building highly available network. And this is not exactly what Kubernetes does with its replica sets. It's actually kind of single-digit second resolution HA configuration. It can be built, and the virtual IP will be available. This will provide a guaranteed failover time within single digits. The way it works, we actually have active and passive, and the passive in a standby mode is already running. So all we need to do is just to very quick operation between the two gateways so that the standby server can take over. So similarly can be done for NFS. Like gateway selection and configure HA as well. So I'll go ahead and create services now. Let me start from iSCSI. I will create also NFS and S3. So I'll look through NFS as well, so you guys also know. So basically, NFS exposes all necessary ports. At the moment, it's NFS version 3 only. Also easier to build it to be fully scale out. So we need to expose pretty much the standard daemons. Obviously they're isolated, they're running in the container. So there's nothing really much special here. The S3 looks like this. The extended S3 implementation is fully compatible with AWS. Obviously, because of the way we're creating the chunks and we're splitting the chunks across the cluster, it's fully immutable implementation with versioning, multi-parts, etc. Supports policies, full spec. What's interesting to note is that when the services will start, they will, and we go inside of one of the services, we will see two networks inside. So let's take a look where we are right now. And let's essentially log in to one of those. Can probably log into, let's say, iSCSI. Okay, so we have daemon running here. We have essentially two networks. One is a pod network, which is 168.0, and this one is underlay network used for the replicast. As you can see, we do not do any IPv6 management on underlay. What we're using is automatically provisioned link local address. If IPv6 is enabled, it is a must to have. So this address will appear automatically. So we're just simply grabbing this address, and this is what becomes essentially part of the communication channel. So caching is supposed to see all the 3 nodes automatically as well. So again, there is zero networking IP address management configuration on the back end.
Yeah, what we want on the back end is we just really want the VLAN assigned. Give us some ports.
Yes, correct, Caitlin, yes. Caitlin, also, if you want to talk a little bit about the multi-tenancy, right? So it's
okay, what Dmitry is demonstrating here is a single tenant accessing the back end. And we could do multi-tenant with multi-tenant logins, but the problem is that some of the daemons we use don't support multi-daemon. And these are daemons that are actually commonly used. For instance, the NFS Ganesha daemon you have to run each tenant in a separate container because Ganesha does not know how to log people into different authentication domains. This is a legacy. NFS daemons were designed in the era when they were going in going in intranets and back rooms. They didn't deal with multi-tenancy. And question?
No, that's me. Yeah, I got Contif working. I wanted to show to the people that Contif is essentially gives us isolation on the pod network for the multi-tenancy, and I wanted to briefly kind of show you guys what Contif does for us. Like for instance, again, I mentioned before that default net was our pod network, and this one was our multi-tenant network with a tenant demo. So if you look at the tenants, you'll see there's a tenant demo. So what we've done here, we kind of connected this networking isolation to the storage isolation. Remember, I created tenant demo also when I was creating a cluster. And importantly to mention that I also, for the purposes of the demo, set up a policy. I limited that tenants to operate only at 100 megabits per second. I then created demo group. I added this policy to that demo group, and there is also isolation policy, which I not enabled, but it can be easily enabled, so we can actually control the flows inside the tenant groups.
Right. The important thing is that there's a second step required, and I have a separate issue open on this. I'll be posting an update to that very shortly. But what isn't what we need for the replicast network can ultimately be dealt with by things that are already part of Kubernetes. What we need for the tenant networks can also be dealt with in ways with Kubernetes, in fact, multiple ways. But one of the things we also want in the long run is the ability to have a shared storage backend that's accessed by multiple tenants. And
correct.
In order to do that and be compatible with iSCSI targets and NFS, and particularly the Ganesha NFS daemon, we need to be able to add a tenant network that interfaces with an existing backend storage network. And that's really what the second proposal is. Now, you can bring up just object storage without that. So doing this in two phases makes a lot of sense, because even if you don't have this dynamic multi-tenant, you have something valuable. So it only makes sense to get that working and then add the multi-tenant.
Yeah, but to some degree, this isolation already provides certain multi-tenancy. So, by the way, Kelly is going to be blogging about this on our mixcenter.github.io website. So if you guys interested to kind of learn more about our thoughts on multi-tenancy and in Kubernetes, please take a look. Let me continue with the demo.
I'll post a link to the website on the issue.
Yeah.
Yeah, when you write that blog post, Caitlin, yeah, feel free to send us a link or put it in our Slack or whatever too, because that sounds like an interesting article to read.
So I wanted quickly to show you how to connect a particular tenant, the storage tenant with a networking tenant. So what we've done here, we set up essentially a label in this deployment where we're mentioning the demo tenant in networking isolation and what network it is on, and this is overlay network and the demo group. Once this is executed, we will take a look inside that container and we'll see how the network is laid out. So let me run it. All right. Get still creating. All right. So essentially, this is what we created so far. Both S3, which is a tenant test, and S3 demo, which is a tenant demo, are using load balancer. Let me just go inside of S3 demo. Yeah, sorry. S3 demo, so this guy. All right, so we have. So what's interesting here is that the client network now picks up their 192.168.2, which is an isolated network, and also has a policy set to limit the bandwidth. I will now go ahead and create a demo pod. Let me cover. So which would essentially, this is how the application essentially can use this multi-tenancy, right? So I want to show you that when we select demo tenant here, the pod will be created, and we should be able to access that network only. The other networks will not be visible, and the bandwidth policy will be applied. So let me just start this demo pod. Okay, I think I forgot to delete it first. All right. Okay, we just go in. Okay, I'm in. All right, so what we've got here is the isolated network, and we should be able to access the demo load balancer. All right, so essentially what we've got is that the S3 endpoint for the demo tenant is only accessible through this isolated network. And now we can do some operations with it. Like, for instance, let me create a bucket. Now this bucket, and again, this is isolated tenant, obviously, right? So the other tenant, which is the default tenant, would not see that bucket. So now bucket is created. And so on. So the other thing is what I also can show you guys, like, for instance, that NFS endpoints are active in. Let me check. Yeah, so this guy is active. Idea here is that we now have essentially Xenta Edge cluster configured with multiple services, exposing two logical cluster spaces and two tenants in one cluster. And we managed to connect this tenant with Contiv isolated network. Essentially, this is about it. If you guys have questions, just shoot me and ask me right now, or I'm available on Slack.
And by the way, we did it with Conteef, but our analysis is that almost any form of network of pod isolation would work for the front end network.
Yeah, that's the idea, right?
And the goal here, of course, like Dimitri mentioned, the bandwidth. What you want with a shared resource network is where you can put limits, aggregate limits on the bandwidth for any one tenant, but the back-end network can actually burst for any one client. It's not like we're building separate back-end networks that are each stuck in the 1/nth slice of the quota. It's a common, and it can pool resources just like a bank pools funds. It makes much more efficient resource utilization. But you want the overall quota through the front-end network to keep any one client from drying up all the resources.
Correct. This is important, but also important to note that once you have multi-tenancy, you can better control incoming and outgoing rules by applying certain criteria.
Right. And it's also very important there's no information leakage across tenants. That customers will not accept that. They want nothing revealed about their operation to people who are in the same data center as them.
Yeah. All right. So that's, Jared, I think this is all on our part. So if you guys have questions, go ahead, shoot. I'm happy to explain if there are any details to ask.
Yeah, thanks, Dimitri, for the demo. One question I have is, so with the with integration of Rook and as another backend, I'm assuming that's the interest in Rook. That where do you see that Rook will help you the most? I mean, I saw some things where maybe you have some things in config map and configuration where those could be CRDs that Rook handles. But what's your vision, I guess, for how Rook helps you with Nexenta?
Yeah, that's great. So Rook will help, I think, in two ways. One is simplify the general configuration between multiple backends. Like, for instance, I do not expect end user to learn multiple management tools. And by providing unified interface, which will be essentially similar to, let's say, if you're talking about MinIO or CF, RGW or Edge, Nexenta Edge S3, it will be kind of similar experience for the end user. So the user who knows how to operate with Rook will be easier, and for him will be easier to essentially get started with MinIO or with Nexenta Edge. So that's number one. Number two, obviously, as you see, there's a lot of YAML files here, right? And those files, essentially, some of them auto-generated during the creation of the service in the GUI or in a CLI, like, for instance, in ADM. If we can have services here listed, etc., and they can be automatically activated and created here as well. But this is still requires an end user to configure a backend, and the backend configuration is not straightforward. So, like, for instance, he needs to go ahead in a typical configuration, modify this file, prepare this config map, as you rightly noticed. The networking backend is another complex configuration point. So if we, let's say, at some point within Rook can solve this separate backend, and I know Kubernetes networking group actually working on adding custom resource definition for the network. So soon we're going to have ability to do this in more approved way, I would say, right?
That's
but not yet. Right now, we essentially end up with utilizing so-called Multus plugin from Intel. I'm going to show it to you really quick. So we do kubectl.
Ultimately, here the goal is almost more to create a convention than a lot of code. That
right.
All these things could have been done with Kubernetes. It would be a real headache for each storage provider and each tenant to figure, each service provider to figure all these out. Having a roadmap that says, here, this is the template on how to plug in multiple storage backends under Kubernetes being outlined by Rook in whatever minimal code is needed to support that. Having that convention is of great value.
Yeah, and I see that with the patterns around CRDs. Let's define what settings we need, and then Rook goes and applies them. And, if we can definitely get those patterns in place and Rook implement it in Rook to benefit multiple storage backends, it'd be
Right,
great.
and streamline the experience for administrators.
Mm-hmm.
Correct. Like for instance, guys, take a look on this description, right? This is row disk definitions for us. This is just extremely bare bone, right? We have like a lot more parameters here to manage. So like have a convention how to define those would be really nice. And so that whatever the user wants to configure the backend, we have well-documented mechanism in Rook.io how to do this. Also, I'm looking forward to see block local persistent volume going from alpha to beta soon. I'm not entirely certain that it is scheduled for 1.11, but I know in 1.10, at least for me, it wasn't working correctly. So I tried the block local persistent volume still not working correctly. So for currently we're using essentially just description of the disks like that, and essentially be forced to pass privileged mode in this case and mount dev directories. That I would like to go away.
Configuration. Right, because he actually ended up doing more configuration work on specific servers than he would have done in our bare metal deployment.
Right. Like
so
local,
it'd be nicer to be able to.
Yeah, go ahead, sorry.
Right, so like normally in bare metal, we have a policy about how to apply SSDs and HDDs.
Yes, exactly.
Rather
like
than
for
requiring the user to explicitly say these drives.
Like for instance, we have this notion where you can specify the journal device, and it could be something like this, right? Like so that journal device then would automatically be used as an SSD offload device for the HDD, etc. Those groups can be kind of built together if you do like this. So these sort of configurations kind of difficult to manage, and I think Rook needs to have a way of essentially building those SSD groups. I noticed that you guys scheduled similar work for 0.9, and I think this is something that would be really beneficial for Nix and the Edge as well. Blinking of the drives is another one. Like for instance, the drive goes bad, how are we gonna handle this error? We need to provide a mechanism to blink the drive, and essentially so it will show up for the end user, this drive needs to be replaced, etc. Right? So all that is something I'm looking forward we can improve with Rook.io in Kubernetes.
Right.
Yeah.
Cool. So yeah, thank you, Dmitry, for sharing this demonstration with us. That kind of helps understand a little bit better about what the experience for Nexenta is. I think the next steps for going further with this would be a like one pager or some sort of short design about what Rook would specifically need to do to help with the deployment and management of Nexenta as a backend. So looking forward to iterating over some of the specifics in that forum.
Yes, that's definitely our next step. We're looking forward for your work being integrated. And maybe even on a branch when you probably can ping us on Slack on the next meeting to say the status on this. We can then start prototyping this. The goal for us was to have some prototype running before the Copenhagen KubeCon, but that would be just a prototype to demo it at the show. if you'll do that in time. If not, then we probably will need to kind of move this to 0.9 time frame.
Cool. Yeah, that sounds good. Definitely. That's my highest priority right now is finishing off the refactor so that multiple providers can go ahead and start hooking into Rook. So I'm going to go ahead and finish off the meeting here with sharing my screen again, Dimitri.
Absolutely. Thank you.
Thank you very much. Appreciate you guys. And this, I think. All right, so the agenda doc should be displayed again here. The last thing that we had on the agenda for today was about PRs that we wanted to discuss, and one that I was interested in was about, we got a PR yesterday from a community contributor about supporting IPv6. When I took a look at it just a couple minutes ago, though, it looks like it was going into the release 0.7 branch, which we don't want. We want it to go into master instead, so we need to change that. But it looked like the basic part of the change here was just how, the string concatenation to define an IPv6 address. And I was surprised that would be the really only thing that was lacking in support for IPv6 and Rook. So if anybody had an understanding of what other lurking issues there may be for IPv6, that's why I wanted to bring it up in this forum.
Yeah, Jared, just one from our experience working with IPv6. Do not forget about the link scope ID. This is often a very forgotten feature, but when you're configuring link local IPv6, you need to specify scope ID that has to be part of the configuration.
Oh, I see. Okay.
And there's also better than link scope, unique local, which we're trying to migrate to. It's kind of like a super gigantic 10 network for IPv6, but multiples of them.
Yeah.
The real problem is the CNI plugins and how they're enforcing the isolation. A lot of them have done it in ways that are IPv4 only. Others of them have done it in ways that are more L2 oriented, which means they can they just support IPv6, and it's just a matter of Kubernetes realizing that it can do it.
And was there any issue open around this or discussion, or all of a sudden the PR just appeared, I think, or resolved?
I think that they opened, the same contributor opened an issue at the same time that they opened the PR, I think.
Okay. Yeah, it'd be great to see more. I guess, will this really answer the IPv6 support, or probably needs more thought here?
Yeah, I agree, Travis, and I guess we could discuss that on the pull request itself and get a better understanding of how they tested it and things like that too, or what their environment was like.
Yeah.
Okay. Yeah, sounds good, Jared. I also will review it in more details. Maybe I can comment something.
Great. I appreciate all your guys' effort.
Okay.
Sure.
Our needs for IPv6 are actually more minor than a general IPv6 solution because we're using unique local and link local addresses only.
Yep.
Cool. Sounds good. We are out of time for today, and that's everything on the agenda document. So I'm going to go ahead and stop the sharing and recording. All righty.